Good morning, ma'am. I'm Pranav Raj, and today we're going to see disk architecture. Okay, so basically, the hard disk consists of large number of disks, which is known as platters, and each disk is further divided into tracks. So this we can see, like there are a lot of disks present in the hard disk, and this disk are called as platters. And this platters, each of them are divided into tracks, and these tracks are further divided into sectors. So as we can see over here, that these are the tracks. Like this is a disk, and this divided into lots of circular tracks, and this tracks is divided by sectors. Okay, so the outer track are bigger than the inner track, but they consist of the same number of sectors, hence have equal storage area. Okay, so all of them, whether it is the inner track or whether it is the outer track, all of them have the same number of sectors, hence the area, like the space present in this the outer sector or the inner sector are same. Okay, so we can also say that the inner track are highly dense than the outer track. Okay, so okay, and then there is something called a read write head, which moves over the rotating disk, and this head is responsible for all the read light operation on the disk. Okay, so this we can see, like as I've already told, like that disk consists of large number of platters. So this is disk. There are a lot of disks which are called as platters, and they are arranged in a stack, and which is fixed by a splinter, and it is capable of rotating. And this is read write head, which is responsible for reading the data or writing the data. Okay, this head is able to move vertical while the platter rotates. Okay, so we can see that this platter rotates. Okay, it has capacity to rotate, and this read write can move vertically, like it can go front or it can go back. Okay, so this can rotate, and this can go front and back. Okay, so this, as we can see, this platters are further divided into tracks, and this tracks are further divided into sectors. Okay, okay, now there are a few terminologies that will help in solving numericals. Okay, so the first one is the seek time. So the time taken by the read write head to reach the desired track from its current position. Okay, so there are a lot of tracks, as we have seen that there are a lot of tracks present in the platter. So the time taken by this read write head to reach that position. Suppose I want to read data from this position, but currently the read write head is present in this track, but I want to read the data from this track. Okay, I want to read data from this position, but it is currently present in this position. So what will it do? It will come back. It will read data from here. Okay, so the time taken by it to come back is known as seek time. Okay, uh, this time is known as seek time. And then there's something called rotational latency, the time taken by the sector to come under the read write head. It is known as rotational latency. Okay, so suppose I want to read data from this part of the this sector, but it is not present under the read write head, and this read write head is also only capable of vertical motion. So it will rotate, this disk will rotate, and this sector will come under this read write head. So the time taken by it to get rotate and come under that head is known as rotational latency. And then there's something called data transfer time. So the time taken to transfer the required amount of data. Okay, it is known as so suppose now if now I have reached to that position from where I have to take the data, and so the time taken by this read write operation to read the data or write the data is known as data transfer time. And then there's something called controller time. So it's the processing time taken by the controller. Okay, it's the processing time taken by the controller, and there's something average SS time. So this average SS time is actually the total of seek time, rotational time, data transfer time, and controller time. Why it is like total of? Because it's the average SS time. Suppose I want to read data from this position. So what will it do? First it will rotate, and this position will come under this read write head, and so that comes under the rotational latency. And then what will do, this read write head will move vertically and come back, and will come to that position where we want to read the data. So that will be a seek time. And then then will be a data transfer time, and then there will be a controller time. Okay, so here is something that is average rotational latency. Okay, so here we have studied rotational latency. It's actually the half of the rotational latency. This average rotational latency is half of the actual rotational latency. Now let's see a question. Okay, so it's given that a hard disk system has a following parameters. So it's given that the number of tracks present in that disk is 500, and the number of sectors present per track is 100, and the number of bytes of data stored in each sector is 500. Now there's something else given, that is the time taken by the head to move from one track to adjacent track is 1 millisecond. Okay, so as we have seen, like time taken from this read write head to travel from one track to another track will be 1 millisecond in this question. So, and there's also rotational speed given, that is 600 rpm, that is rotation per minute. Now what is the average time taken for rotating 250 bytes from the disk? Okay, so what will be our average time to transfer? First one will be the average seek time, and the second one will be the average rotational delay, and the third one will be the data transfer time. Okay, so what is asking? It asking the transfer of 250 bytes of data from the disk. Okay, that we have to keep in our mind. Okay, so now let's see how we'll calculate the average seek time. So it's what? It's actually the time taken time taken to move from one track to the from first track to the uh, first sector. So okay, so initially it will present at some position. Okay, let's see this with the diagram. So there are a lot of tracks present in the disk. Okay, so what it will do, it will come from one track to another track, and then from another track to this track to another track. So it's the time is given that it's taking 1 millisecond to transfer from one track to another track, and there are total 500 tracks, right? So at present it will be present in some track. That's why the first track is 0. The first track is 0, and then from first to second track will be 1 millisecond, and then from it will like go on 2 millisecond, 3 millisecond, and 499 milliseconds. So it's given in the question, like time taken from by the head to move from one track to the adjacent track is 1 millisecond, right? So this is the seek time, and we have to find out the average seek time. So it will be the summation of all the seek time for all the tracks by the total number of tracks that is present, that is 500. It will be 249.5 millisecond. And then there is something called we have to find average rotational delay. Okay, so average rotational delay, so we have given that there are 600 rotations per second. Okay, so that clearly represent that one rotation takes 0.1 second. So in 0.1 second the complete rotation is performed. Now we have to find out, so this 0.1 will be our rotational latency, and since we have to find out our average rotational delay, that will be divided by 2, that is 50 milliseconds. Now there comes data transfer time. So what is this data transfer time? So it's basically in one rotation we can read data on track. Okay, so in one rotation how many datas can be written? So okay, in one rotation it will cover all the tracks. Okay, like it will cover a single track, right? It will not cover all the track. It will cover a single track. So in a single track we have like 100 sectors. Okay, and in we have 100 sectors, and in each sector we have 500 bytes of data stored. So the total data that will be it will read will be 500 bytes of data. Okay, this is the amount of data that will be written in one rotation. Now we have to actually find for 250 bytes of data that is present in that disk, right? So 250 bytes of data would be 0.1 into 250 by 500. So this is basically finding out 250 amount of time, like 250 by 100, like 250 data, how many what time will be taken by the read write head to do that. Why we are taking 0.1 second? Because one rotation is performed in 0.1 second, that will give me 0.5 millisecond, and therefore we have something that is we have to find, that is average time to transfer the data. That will be the sum of all this: average seek time, average rotational delay, and the data transfer delay. So the sum will be 300 millisecond, and hence our answer will be option D. Okay, so thank you.